live on 8:30 Prep. Hi, I'm Phil McCaffrey, and we're coming live from the 8:30 Prep 3R Prep Studios in historic Ambridge near the Old Economy Village if you want to come down and visit me once social distancing is over.
So don't invite anybody over just yet.
Yeah, it's just me and you.
Stay home for now. That's why we're broadcasting live.
Teo is helping me out. This is my stepson. So we live together, so there is no social distancing. We are going to go and have dinner together. We're talking about trigonometry on the ACT. I am an expert SAT, ACT tutor. I've been tutoring standardized tests for well over 26 years now. When I started with a little company known as the Princeton Review, when it put an ad out in the old-fashioned newspaper, I was in graduate school just getting out of the Navy, and I decided to look for a job, and I looked under education, and it said, wanted, witty and irreverent high test scores. And I had just killed the math section on the GRE to get into graduate school, so I gave it a try. And I taught the class, and lo and behold, I loved the patterns and figuring out how to do it. To me, there's a lot of fun to this because it's like cheating. And so today, I'm going to teach you about one problem that shows up occasionally. So this isn't really a big, important one. Next week is very important, and I'll be marketing that. That is geometry on the ACT and the SAT. But today is trigonometric functions. Like we talked about all week long, there are 4 trig questions on the ACT. This has been a standard on and off. Sometimes there's been more, sometimes there's been less, but the average has been 4. 2 of them are SOHCAHTOA. We went over those. The basics of right triangle trigonometry, and then inverse functions as well as reciprocal SOHCAHTOA. Yesterday we did the unit circle. Today we're going to do trigonometric functions. And there's some really cool videos. I'm sure that your math teachers, your physics teachers have shown you that when you go around the unit circle, they show you the sine wave that it happens. The really cool thing is that sine waves were discovered in mathematics before they were actually used in the practical world, and then it turned out that everything uses a sine wave. I mean, your cell phone communicates to the cell tower via a sine wave. I'm coming to you via YouTube live via a sine wave. Electrons move via a sine wave. It's really, really cool, and it's used extensively in engineering and medicine and finance and all kinds of things. So it's important. Most of you probably won't use it, but if you're looking to get a very high score on the ACT, you got to know trig functions, and they're very easy. They only ask certain things. So let's talk about basically what a trig function is. How does the board look, Teo? Am I sitting right? Sitting good here? Got my 3R Prep hoodie on. It's wearing out after all these years. So a trig function, the basic or parent trig function, uses a sine wave, and that's called a sine wave. And it starts out where sine is 0, so at 0, 0, and it goes up to 90 degrees, or pi over 2, back down to pi at 180 degrees. So I'm going around the unit circle, down to, this is 270 degrees, this is 180, and then we're back to 360 degrees. And that goes all the way around the unit circle. The 2 most important things that they talk about is the amplitude. And the amplitude of a sine wave is defined as the length from the x-axis to the peak of the wave up at 90 degrees. So as we know, sine equals 1 at 90 degrees. The coefficient here is 1, so that's the amplitude. So we want to work on amplitude. The second thing is the period, and the period of a sine wave is going all the way around the unit circle what all the sine values are. So that's going all the way around every single value of every degree. And the period of the parent function, the amplitude of the parent function is 1. The period of the parent function is the circumference, 2 pi r is 1. All right, let's take a look at the only other trig function that I've ever seen on an ACT. I've never seen this on an SAT yet, but that doesn't mean it's fair game, and that's a tangent function. And the tangent function has this goofy little wave like this, and they go kind of parallel, that's not the right word to use. I'm trying to so that they go in the same way. What's a parallel? They're not parallel because they're not parallel, but the points are the same distance apart. The amplitude of a tangent function is undefined. This is very important because trigonometric functions, the sine over the cosine, as the sine or the cosine gets to be 0, the trig function approaches infinity. The period of a trig function is right here between the two functions. So our period of a trig function, of a tangent function, is equal to pi. So the period of the sine and cosine function is 2 pi. The period of a trig function is pi. I've only ever seen this to be identified. They show you the graph and they ask you what it is and you say tangent, and that's it. Okay, let's look at a more complicated sine function. I just drew this one. I should have graphed it out with a graphing calculator, so it's a kind of wonky trig sine wave. Starts off at 0. But the most important thing is that there are 4 portions of a standard sine function, and that is amplitude, b, which affects period, h and k, which is horizontal and vertical shifts. So we've got 4 things. We already talked about it, and that is the amplitude. The coefficient a in front of the sine function is equal to amplitude. And that is one of the reasons. Amplitude. Can't even spell. Then it's sine b of x times the quantity x minus h, where b affects the period. So the period of the sine function is 2 pi divided by this b coefficient of x. H and k affect horizontal and vertical translation. And let's do something fun here. H moves the sine waves left and right. Ooh, look at that. It's almost like animation. Gotta love whiteboards. And K moves it up and down. This way and this way. I have seen questions about that, and let's go right into them. Here's a question off of a ACT official practice test. Let's make this bigger so we can see it. Let's stretch that out a little bit. And it says the functions y equals sine of x, the parent function, which would be this one right here, and y equals the sine of x plus a, which would be this one right here, plus b, for constants a and b, are graphed in the standard xy coordinate plane below. The functions have the same maximum value. This is extremely important. Phil's rule number 1, read with your pencil, underline key words. Of the following statements about A and B, one of the following statements about A and B is true. Which one? Which statement is true? Let's take a look at it. Well, what do we have here is we just talked about H and K, where H moves the function horizontally. Well, if you'll notice here, this is actually a sine and a cosine wave. A cosine wave is a sine wave shift. So this right here is H. So H might be positive or it might be completely negative. It could be pushing it all the way over from here to here. So H could go this way or that way. We're not sure. We're not sure if A is positive or negative, and that's where A is positive or negative. One thing is true, A is not equal to 0 because there is a horizontal shift. Now the key thing is there is this maximum value, and the maximum value is the same, and so is the minimum value. This function here, B, controls the horizontal shift. There is no horizontal shift. So the only thing we know about A and B is that B is equal to 0. The correct answer is A. I love this question. It's like functions. We'll do a week on functions where the function of x If I add c to it, it moves up. If I subtract c to it, it moves down. That's all they're asking here. So even if you're not in trigonometry pre-calculus and you don't know this, you do know functions up and down, left and right. That actually starts in Algebra 1 with translations and inverses of functions. I know because I just tutored a student on Algebra 1, and there's the book right there, and I was geeking out reading an algebra book. Notice this is a number 57, and it's pretty easy. A 55. Something to notice about trig functions, they're almost always in the last 5 questions. This one says the equation of two graphs shown below are y1 is equal to a1 sine b1 of t, a2 of t is equal to a2 of cosine of b. Sine starts at 0, cosine starts at 1, and they both have an amplitude. Which of the following statements is true concerning the constants a1 and a2? These are the amplitudes. This is what's in front of it. So let's take a look at the sine wave, and the sine wave here has this amplitude. The cosine wave has this amplitude. So this is a2. This is a1. a1 is greater than a2. They're both greater than 0 because if the amplitude was 0, it would be a flat line. a1 is greater than a2. The answer choice is B. A very good question, a very easy question, and a number 55 that you can answer under a minute. Most of the questions in the 50s take multiple minutes, so you want to do your first 20 as fast as possible. If you're a high-end student, one thing that I recommend is getting a bunch of old TIRs, I always talk about this, and practice 1 through 20 in 5 to 7 minutes so that you can have more time on the harder problems. Questions 21 through 40, you should still be able to do those in under a minute because questions 40 through 60 take more than a minute, except for this one, which would take you about 15 seconds if you know what amplitude is. All right, now here's one that's a 35. I did say they usually appear in the last 5, but this one appears at 35. It's a pretty, 38. It's pretty early on. 38 is right when the problems get hard. I usually say around 40. So the first 20 are easy, the middle 20 are medium, the last 20 are hard. So this is a shift from medium to hard. And it says the function f of x is equal to 0.25 sine of 4x. It's graphed below where x is greater than 0 and less than 2 pi, meaning x is anywhere on the unit circle. What is the period of the function? Well, a period is peak to peak or point to point. So it's an entire cycle of the wave. That's the period. Right there. That's the period, what I just drew with red. Notice this. It's a lot shorter than pi. And it's certainly a lot shorter than 2 pi, which are 2 of the answer choices. So I can eliminate it. On the ACT, there are 5 answer choices on math. All of the other sections only have 4 answer choices, but there are 5 answer choices on math. On a multiple choice test, it's just as important to know what the wrong answers are as to know the correct answers. And in this case, as we talked about before, period is equal to 2 pi over b. And b here is 4. So p equals 2 pi over 4, which reduces to pi over 2. Answer choice F. We can figure this out by the graph. And do I have one more? Yes, I do. Which of the following trigonomic functions has an amplitude of 2? Notice we've talked about amplitude and period. A little bit about phase shift. Not much about left and right. A little bit about up and down. The amplitude of a trig function is 1/2 the non-negative difference between the maximum and the minimum values of the function. So the non-negative difference, so here's a sine wave, here's the maximum, here's the minimum, it's halfway in between. An amplitude of 2. Well, you already know my trick, and that is f of x is equal to the amplitude times the sine, cosine, cosecant, or secant, and not the tangent. The tangent has an amplitude that is undefined. Notice the a, the coefficient, in front of h, j, and k. 1, 1, 1/2. The answer is f. 2 sine of x. That's the amplitude. These are pretty easy problems if you're a trig student. If you're not a trig student, they can be impossible. But I hope you've enjoyed this and you could study this and figure it out, because you're going to see it on the ACT about 30% of the time, I think, somewhere around there. It was hard for me to find these, so it's not really that great. It was a quick lesson. How long did we take? 17 minutes. That was lesson what I call M403. Tomorrow's law of sines and cosines. I hope you tune in and I hope you watch it. Thanks everybody for watching. Ben, you loaded up these problems for homework. I did. I sent this out to North Catholic for homework. I loaded it. Ben, just wait till next week when you're going to get 2 weeks. You're going to have 4 days of homework. I'm going to give you 2 weeks, and we're going to do it all week, and then I'm going to give you a week off. How's that? Is that fair? So all of my North Catholic students get a whole week of geometry and then a whole week off. So I'm Phil McCaffrey. Thanks for watching 830 Prep.